Do you need a bench power supply to fit your needs but they're too expensive or take up too much room on your workbench? Do you have varying voltage needs for charging or projects but can't find a charger that meets your needs? What if we could build one for $30? I have this Xbox power supply that's lying around the house, and I no longer use the Xbox, so why not make some use of it? Let's start by cutting off the end. I'll expose the wires with my utility knife. Once the insulation is stripped away, you can see there are 2 black wires, 2 yellow wires, 1 blue and 1 red wire. I'm going to expose each wire so we can connect them. In order to get power out of the PSU, you need to tie the red and blue wires together. This takes the unit out of standby mode. I prefer to solder the wires together, but you could simply twist the wires together and re-insulate. You could also connect a switch here if you plan to leave the unit plugged in all the time. Then, I re-insulate with heat shrink tubing with adhesive. I'll leave a link in the description for you. Apply some heat with a heat gun. You could also use a hair dryer or a lighter if you don't have a heat gun. Strip the remaining wires and solder them together so they become one wire. I find it easier if you pre-solder the wire ends before joining them together. Now, I will solder the connecting wires together. Protect the wires with heat shrink tubing. Now, let's bundle them all together. No one will ever know the difference. Haha. Pre-soldering the opposite end before applying to the connector. Don't forget to slide on your heat shrink tubing before soldering the XT60 connector. Slide the tubing up to the connector and apply heat to it. If you think this is a helpful video, hit that like button so others can see it too. Thanks. This power brick will put out 12 volts, a whopping 16.5 amps, and your 5-volt wire will put out 1 amp if you choose to use it, say for instance, as a USB connector. Now we can connect this power supply module that I got off of Amazon. I'll leave a link in the description for you, but it's a step-down converter. It's capable of converting power from 1 to 32 volts at 12 amps or less. Now, if you combine this with the Xbox PSU, you're only going to get 1 to 12 volts. There is a fix to that, and I will cover that later in the video. The top left button toggles between the in and out voltage on the display. The bottom left button is the on and off for the voltage going out. The far bottom right corner is your current regulator. And beside it is your voltage regulator. Right above that is your LED indicator for your constant current, and the on indicator. I'm going to demonstrate how this works by charging my shop light. We can set this to 5 volts or less. This is similar to a USB output. First, turn it on. The green indicator will light up, then adjust the regulator to the desired output. Once achieved, turn it off and tie the output ground and positive wires together. Then turn it on and adjust your current regulator to the desired amps. As you can see, it's charging. Now, let's see how many volts we can get out of this thing. We can achieve that by adding a step-up boost converter. This is capable of 10 to 32 for input volts and 12 to 35 for output volts. Max input current is 16 amps and max output current is 10 amps. Perfect for our needs here. Here I will demonstrate its capabilities. First, switch your toggle button so your display shows the incoming voltage. Adjust the voltage regulator on the step-up booster. I'm going to set it to 32 volts. Then, toggle to your out voltage and let's find the max voltage we can get. We achieve 31.8 volts. That is normal because our input is 32 and you will lose some power. Let's double check with a voltmeter. We achieve 31.5 volts. That is normal because with the anti-backfill diode, you lose between 0.2 to 0.4 volts. With this setup, that's pretty good. At the cost of $30, you achieve 31.5 volts and hopefully 10 amps. But that's to be determined. The diode is only needed if you are using it as a battery charger. If using it as a bench power supply, the diode is not needed. Now let's see what it can really do. I have here 6 battery packs that are configured in 3P3S, 3 cells in parallel, 3 cells in series. That's 54 cells in total. At full charge, one battery pack would be 12.6 volts. Let's set the step-up booster regulator to 15 volts. Let's set the output voltage to 12.8. We are going a little high because of the loss we are going to get from the diode. We are going to verify the volts. You see the multimeter confirms 12.8, but no current is flowing through yet. We will have to check again once connected. Let's set the amps. Tie the positive and ground wires from the power module together and then turn the unit on. Adjust the current regulator. Here I am going to start low and will bump up the amps once I start charging. I am using alligator clips to connect for ease of connecting and disconnecting for testing purposes. But this does add resistance to the circuit. This is next to no power, but as you can see, all battery packs light up. It's roughly 1 amp for 54 cells. That is only 0.02 of current per cell. Let's see if we can achieve 10 amps. Nice, we achieved 10.5 amps. Let's go. I want to turn it down to a safer 8 amps because I don't want to run the module to its max. Plus, anything over 8 amps for this module, you should add an additional air cooling, like a fan. Now we are going to verify the voltage drop from the diode. The reading is 11.8. The difference is 0.5 volts loss of power from the diode. You need to be mindful of this when you set your voltage. Let's confirm the amp reading from the power module with the multimeter. With my multimeter, I am unable to take the amps higher than 5.4 because of the way I have it connected. With all of the extra wiring adds resistance. If someone wants to confirm this, please comment below. We can confirm that the readout of the power module matches the multimeter, so it's a good confirmation. Remember, the diode only affects the voltage, not the amp reading. Now, after combining these 3 components together, I no longer have the need for a store-bought bench power supply or battery chargers. I save space and money. Plus, I really enjoy building my own. Thank you for watching and liking my video. Subscribe so you can see what happens next with this project, where I'll be meshing all of these components together and more. I will leave links in the description on everything that was covered in this video. You can check out my other videos here or continue following this series here. As always, happy building.